So we have a little presentation that has to do with using a LabVIEW dashboard. And last year we had the capabilities to use a LabVIEW dashboard from any programming software. I know our team found that the console was much more useful because it was easier to use. But this year, my understanding is that we're going to be able to read a LabVIEW dashboard while we're playing the match because of the way the classmate works. So you can use the default dashboard and send data back to it that way, but we found that the ways to display the data weren't very helpful to the way our robot was designed. So we went about customizing this dashboard project into something that was more useful for us. And so we're just going to show you, first of all, what we came up with. And we're also going to show you how you would go about making a small change to the dashboard. So this is the dashboard we've come up with. You can see it still has the same camera windows and the battery windows as the default dashboard, but we've added some of our own controls to it in the place of where the ordinary motors were. So if we just enable the robot, you can see we're also using the driver station software on the regular development CC. So if we move around the motors, you can see the indicators change value. And we would have liked to use the camera window to display communications from the Axis camera, but unfortunately the C++ libraries did not handle that for the Bay teams or haven't yet. So we weren't able to do that. So what we're going to show you now is how you would go about modifying a dashboard. In this case, we're going to show you how you do it using C++ on the robot and the LabVIEW dashboard. If you're going to do it in Java, it would be very similar to this. Some of the function names are a little different, but not by much. And if you're using LabVIEW, it's going to be a little nicer to you. I believe there's a block that allows you to send data back to the dashboard. But with C++ and Java, it's a little more complicated because you're going across platforms. So to start off with, what we're going to do is we're going to add some sliders, just like the blue ones there, that are going to tell us when our robot moves forward and back and when it turns. It's going to basically give us the values from the joystick. So we're just going to add 2 sliders and name them. And so by default, the sliders go from 0 to 100, and that's not particularly useful for us because our joysticks go from -1 to 1. So what we're going to do is we're going to change the scale so that the sliders go -1 to 1, and that'll make it easier for us to pass data to them. So if we go into the properties window, if it loads, there's a scale tab, and this is where we're going to set. It's fairly intuitive. And we'll just do the same thing for the other one. Okay. So now what we're going to go to is called the block diagram. And this is where all the LabVIEW code actually takes place. Okay, so if you're programming LabVIEW, or if you have last year, you've seen all kinds of views. This is the meat and potatoes of a LabVIEW program. So how this one particularly works for our purposes is it takes a data string from the robot, and it puts it through here, and it gets to this block, and this block takes that string of characters and translates it into useful variables. And the reason it knows how to do this is with use of a constant called the dashboard data type, which is over here. And the dashboard data type contains the format of how you want to send data back and forth from your robot. So what we're going to need to do is modify the dashboard data type to take 2 extra doubles, because that's what we want to pass in 2 extra floating point variables. So if we go to our project explorer, you see we've included a file called dashboard.datatypes.ctl. Normally this is on your robot project, so what we've done is we've copied this back to the dashboard project. So if we open that, and we're going to add 2 new numeric controls here. And one's going to be for the joystick x-axis and one for the y that we're passing back. So now what we need to do is copy this into our robot project. So Control A, Control C, and we copy it back in here. And you can see there's been 2 variables added to the end of it. Other than that, it's exactly the same. So we're just going to drag it over and wire it up where the old one was. And now, if you look over in this section of the screen, there's 2 new double variables that have been added to this block here. And so we're going to wire those up to our indicators, which are up here. When you initially put the indicators down on the screen, it seems to be pretty random where they wind up on your block diagram. So you're going to have to play a little game. It's a lot of fun. So we've wired. Have you wired these up? Yeah. Okay, so we've wired these up. There is a problem. I'm not sure if you can see from where you're sitting, but the indicators have a U8 at the bottom of them. That means that they're designed to take an unsigned 8-bit integer as their input, and we're trying to send them a double. So what we're going to need to do is change the properties of these. And under properties, same place where we change the scale, there's a tab called data type. And we're just going to click adapt to source, and it'll automatically change to a double, or whatever kind of variable we hook it up to. And that's pretty much all we have to do on the LabVIEW PC side of things. So now what we're going to have to do is change our C++ code so that we're able to send data back to the computer from the robot. And the way this works, I'm just going to show you. There's a dashboard class, and this was included with the 2009 code as well, so if you want to use it, feel free. And you can see there's a whole bunch of add functions, and there's a printf function, which is kind of nice if you like your console output and you want to use it. You can send printf messages back to the dashboard. But for the data that we're using, we're going to send it in the form of the add functions, and then we're also going to need to use the finalize function. So I'm going to show you kind of how these work together with the magic of PowerPoint, if I can just figure out where I saved it.